Hello students, today our topic is food analysis. Under that, objectives are to evaluate raw materials and finished products in terms of size, shape, textural properties, pH and water, enzyme activity, total acidity, specific gravity. Now the introduction part coming to a raw material also known as a feedstock or most correctly unprocessed material is a basic material that is used to produce goods, finished products, energy or intermediate materials which are feedstock for future finished products. In food industry, foods are analyzed for chemical composition and characteristics either for nutritional labeling or quality control. The food analysis are carried continue within processing or sampling collected for quality control or sent to outside analytical laboratory. In the quality control, sampling and preparation of sample and interpretation of results are very important. The methods of analysis depends on the objective of testing. Methods used during processing and final products are rapid, while those used for suppliers of raw ingredients and nutritional labeling of final product are time consuming and accurate. Interpretation of analysis results is of far more important. Food analysis is being done by wet chemistry, spectroscopy, chromatography, etc. Generally, food or its ingredients analysis is required as demanded by consumers' requirement due to competition in food industry and for interpretation of government regulations and international standards. As safety, quality, nutrition and good value are important to consumers, it has become increasingly challenging task to food industry to meet their demands. Similarly, consumers interact to food safety has increased the testing for allergens and pesticide residues. GM crops are nothing but genetically modified crops have also necessitated testing for food and raw materials. Consumer concern about relation between diet and health has increased the importance of testing of foods to allow certain nutrient content claims. Example, low fat and health claims, that is dietary saturated fat and cholesterol, and the risk of coronary heart disease. Now we will see about the characterization of raw materials. Manufacturers measure the properties of incoming raw materials to ensure that they meet certain minimum standards of quality that have previously minimum standards have been defined by the manufacturer. If these standards are not met, the manufacturer rejects the material. Even when a batch of raw material has been accepted, variations in its properties might lead to changes in the properties, might lead to the analyzing the raw materials. If it is often possible to predict their subsequent behavior during processing so that the processing conditions can be altered to produce a final product with the desired properties. Example, the color of potato chips depends on the concentration of reducing sugars in the potatoes that they have manufactured from. The higher the concentration, the browner the potato chips. Thus, it is necessary to have an analytical technique to measure the concentration of reducing sugars in the potatoes so that the frying conditions can be altered to produce the optimum colored potato chip. Now, monitoring of food properties during processing. It is advantageous for food manufacturers to be able to measure the properties of foods during processing. Thus, if any problem develops, that it can be quickly detected and the process adjusted to compensate for it. This helps to improve the overall quality of a food and to reduce the amount of materials and time wasted. Example, if a manufacturer producing a salad dressing product and the oil content became too high or too low, they would want to adjust the processing conditions to eliminate this problem. Traditionally, samples are removed from the process and tested in a quality assurance laboratory. This procedure is often fairly time consuming and means that some of the product is usually wasted before a particular problem becomes apparent. For this reason, there is an increasing tendency in the food industry to use analytical techniques which are capable of rapidly measuring the properties of foods online without having to remove a sample from the process. So, students, these are the techniques which allow problems to determine much more quickly and therefore lead to improved product quality and less waste. The ideal criteria for an online technique is that it is capable of rapid and precise measurements. It is non-intrusive, it is non-destructive, and that it can be automated. Characterization of the final product. Once the product has been made, it is important to analyze its properties to ensure that it meets the appropriate legal and labeling requirements, so that it should be safe and it should be highly quality. It is also important to ensure that it retains its desirable properties up to the time when it should be consumed. Now, evaluation of raw materials and finished products. To maintain product quality, food industry should apply different analytical methods right from the raw material to the final product. Analysis of different types of samples in the food process will help to the success of the business. Maintained quality of raw material will produce further testing of final product. Some of the food industries sets the responsibility of analysis of raw material to suppliers, and some of the industries have select suppliers who are given detailed ingredients to ensure quality specifications. Sometimes these companies may insist to have test sample for checking before placing bulk order. So, now we will see about the samples analyzed in quality assurance program in food products, sample types and critical points which each type should be seen. The sample type is raw material and the critical points which we have to see are: do they meet your specification? Do they meet required legal specification? Will a processing parameter have to be modified because any change in the composition of raw materials? Now, process control sample and critical points are: did a specific processing step in a product of a acceptable composition or characteristics? Does further processing step needed to be modified to obtain a final product of acceptable quality? Now, next sample type is finished product. Does it meet legal requirements? What is the nutritive value so that label information can be developed, or it is the nutritive value as specified on an existing label? Next type is competitor sample. What are its composition and characteristics? How can we use this information to develop a new product? Next one is complaint sample. How do the composition and characteristics of the complaint sample submitted by a consumer differ from a sample with no problem? Now, standards of identity for certain food products. These include which ingredients a food must contain, the minimum levels for expensive ingredient, that is fat, and recommended analytical methods to determine the chemical composition. Information regarding food analysis for standard of identity for several food products is precised. So here we are going to see the item on every nutrient and analysis how it is going to be taken. For calories, calculated from total fat, and total fat it should be analyzed for extraction with petroleum or diethyl. Iron, chromatography, and then vitamin C 2,6-dichlorophenol, endophenol chromatography. International standard analysis of raw commodities and processed food product. These standards make necessary the analysis of raw agricultural commodities and processed food products being imported or exported, to ensure quality measures set by not only of individual government but also standard set by international organization. Standards set by the Codex Alimentarius Commission to facilitate international trade of foods. These standards are published in the Codex Alimentarius. Now it is very important to see the steps which will be involved in the analysis. Actually, three main steps will be there. First one is selection and preparation of sample and actual analysis, and next calculation and interpretation of results. Selection and preparation of sample. Sample collection and sample preparation methods are important to ensure representative sample is being analyzed. So, the sample mainly affects by four factors: purpose of the inspection, nature of the product, nature of the test method, nature of population being investigated. Sampling of heterogeneous sample is difficult in order to get representative sample. Three types of sampling plans are being practiced: single, double, multiple. No sampling plan is free of risk. Risk may be of consumer risk or vendor risk. The consumer risk is the probability of accepting a poor quality product. The vendor risk is the probability of rejecting an acceptable product. Sampling may be done manually by a person or continuously using some mechanical system. If conducted properly, the continuous sampling should be less prone to human bias than in manual sampling. Though sampling is statistically sound, non-probability sampling is unavoidable. Probability sampling is the statistically sound to obtain a representative sample and eliminate human error. Most samples collected for analysis be clearly labeled in the preparation of samples for analysis. Samples collected for official or legal purposes must be sealed to protect from tampering, and the chain of custody must be clearly identified. Now, the preparation of sample. The official method of analysis, also called as AOAC, gives detailed instruction of the preparation of specific food samples for analysis, which is determined by the nature of the food, and the type of analysis is to be done, which includes size of the samples collected, particle size reduction, and storage of samples. Samples that are too large in mass be reduced by reducing the sample on a clean surface, dividing into quarters and collecting the two opposite quarters. The process can be repeated until a sample of manageable size is obtained. Grinding is used commonly to reduce particle size so that more homogeneous samples can be obtained, and samples are suitable for analysis. Various types of milling are used for grinding and reducing particle size. A common concern in grinding is the loss of moisture due to air exposure or heating. Freezing, drying, and chemical preservatives may be used alone or in a combination to prevent microbial problems. Analysis. The actual method of analysis to be adapted is of critical factor. Some analytical methods are very robust and can be applied to all food types, but most methods are not widely applicable. The food composition can affect the performance of many analytical methods. Fat, protein and carbohydrate are the three major food components expected to have the strongest effect on analytical method performance. Example, the high fat or sugar content of certain foods can cause interferences in some assays. Calculation and interpretation of result. Extraction steps and digestion procedures can be necessary and specific depending on the food matrix. Because food systems are quite complex and varied, our technique for analysis of a particular component cannot to be applied to all foods. Availability of official methods has been made easier to the choices of the methods for specific food components and characteristics. Such official methods have been carefully developed, standardized and compiled by several scientific organizations. These methods also provide a way to evaluate new and more rapid assays. Association of Official Analytical Chemists. As I told you earlier, AOAC is such an organization which provides methods that perform with an accuracy and precision under usual laboratory conditions. Members of AOAC select, publish methods or develop new methods and then laboratively test the methods in their own laboration. If methods are found acceptable, they are adopted as official methods and published in the official methods of analysis. This is the published every 4 to 5 years and cover wide range of products and the materials. New methods and revisions to current methods are published in supplements to the most recent edition of book. Some of the other books of official methods of analysis related to food and ingredients include Approved Methods of Analysis published by American Association of Cereal Chemists, Official Methods and Recommended Practices published by American Oil Chemist Society, Water Waste jointly by America's Public Health Association and American Water Works Association. During analysis of food products, a proper precautions such as use of blanks, sources of contamination and other potential sources of error, that is equipment and analyst technique, are to be taken. Some of the sources of error in analytical methods are often overlooked, especially when laid with a set of questionable data. The analyst or supervisor must do some problem solving and identifying the factors that contribute to the problem. Some of the sources of error that can be cause data gathered in inaccurate and low precision. Validity of data obtaining using a specific analytical method can be assessed in multiple ways. A common test of validity in assessing the inherent characteristics of the method including accuracy and precision. Of major assistance in assessing accuracy is the use of standard reference material which can be obtained from different organization. Control samples internal to the laboratory also can serve as a standard reference material. Now we will see the size and shape of each structure. The structural organization of the components within a food also plays a large role in determining the physiochemical properties, quality attributes and sensory characteristics of many foods. Hence, two foods that have the same composition can have very different quality attributes if their constituents are organized differently. For example, a carton of ice cream taken from a refrigerator has a pleasant appearance and good taste. But if it is allowed to melt and then be placed back in the refrigerator, its appearance and texture change dramatically and it would not be acceptable to the consumer. Thus, there has been an adverse influence on its quality even though its chemical composition is unchanged. Because of an alteration in the structural organization of the constituents caused by the melting of ice and fat crystals. Another familiar example is the change in egg white from a transparent viscous liquid to an optically opaque gel. When it is heated in boiling water for a few minutes, again there is no change in the chemical composition of the food, but its physiochemical properties have changed dramatically because of an alteration in the structural organization of the constituents caused by protein unfolding and gelation. The structure of a food can be examined at a number of different levels. First one is molecular structure. Ultimately, the overall physicochemical properties of a food depend on the type of molecules present, their three-dimensional structure and their interactions with each other. It is therefore important for food scientists to have an analytical techniques to examine the structure and interactions of individual food molecules. Next one is microscopic structure. The microscopic structure of a food can be observed by microscopy but not by the unaided eye and consists of regions in a material where the molecule associate to form discrete phases. Example, emulsial droplets, fat crystals, protein aggregates and small air cells. Macroscopic structure. This is the structure that can be observed by the unaided human eye. Example, sugar granules, large air cells, raisins, chocolate chips. Shape and size. Size, physical characteristics of raw, unprocessed as well as processed food materials include particle size and shape, particle and bulk density, porosity and surface area. The size and shape of a raw food material can vary widely. The variation in shape of a product may require additional parameters to define its size. The size of spherical particles like peas or cantaloupes is easily defined by a single characteristic such as a diameter. The size of non-spherical objects like wheat kernels, bananas, pears or potatoes may be described by multiple length measurements. The longest diameter, that is major, and the shortest diameter, that is minor, will adequately describe the size of an ellipsoidal object such as grain kernel or potato. The two dimensions are usually measured perpendicular to one another. The size of pear-shaped objects such as pears, carrots or beets can be expressed by diameter or circumference of the largest part and an overall length in the direction of the stem. The size of irregular shaped materials like bananas, okra or squash requires more extensive considerations. Particle size is used in sieve separation of foreign materials or grading. Example, grouping into size categories. Particle size is particularly important in grinding operations to determine the condition of the final product and particles size. Small irregular shaped objects can be sized with sieves by expressing particle size as the smallest sieve by expressing particle size and opening through which the particle passes. Precise methods incorporating optical, light or lasers in machine vision systems exist to define shape and size of irregular shape objects. Shape. Shape affects the grade given to fresh fruit. To make the highest grade, a fruit or vegetable must have the commonly recognized expected shape of the particular fruit or vegetable. Misshapen fruit and vegetables will be downgraded and may sell at a lower price in high volume markets. The shape of an irregular object can be described by terms such as the following: shape and description of each shape: round, approaching spheroid; obligate, flattened at the stem end and apex; oblong, vertical diameter greater than the horizontal diameter; conic, tapered towards the apex; ovate, egg shaped and broad at the stem end and oblate, inverted oblate; elliptical, approaching ellipsoid; unequal, one half larger than the other; ribbed in cross section, sides are more or less angular; regular, horizontal section approaches a circle; irregular, horizontal cross section departs materially from a circle. Now we will see about the texture. The texture of raw materials is frequently changed during processing. Textural changes are caused by a wide variety of effects, including water loss, protein denaturation, which may result in loss of water holding capacity or coagulation, hydrolysis and solubilization of proteins. Raw materials must be chosen so that the texture of the processed product is correct, such as canned fruits and vegetables, in which raw materials must be able to withstand heat processing without being too hard or coarse for consumption. Texture is dependent on the variety as well as the maturity of the raw material and may be assessed by sensory panels or commercial instruments. One widely recognized instrument is the tenderometer, used to assess the firmness of peas. pH and water. An essential element of any recipe is water, the importance of which is very often overlooked. Water activity, that is AW, has its most useful application in predicting the growth of bacteria, yeasts and molds. For a food to have a useful shelf life without relying on refrigerated storage, it is necessary to control either in acidity level, that is pH, or the level of water activity, as I told you, AW, or a suitable combination of the two. Water is also an important raw material in the food industry. Enzyme activity. Enzymes plays an important role in the food industry in both traditional and novel products. A large number of enzymes are found in milk. Alkaline phosphatase, lipase and xanthan oxidase are significant for a food material. Hydrolytic enzymes found are lipases, phosphatases, amylases, proteases and aldoses. Decomposing enzymes are catalase, redoxo enzymes, reductase, peroxidase and xanthan oxidase. Lactanin is the germicidal factor present in the milk. Flavor is an important characteristic of milk and its products, and hence correct handling, processing and storage is essential for retaining the original flavor. The soluble constituents, lactose and minerals impart this acceptable sweet flavor. Milk, fats, fatty acids and their oxidation products also contribute to it. A flavor defect can rise from fatty feed, bacteria, enzymes and chemical reactions. The major group of spoilage bacteria in milk are lactic acid, butyric acid and enzyme producing bacteria. A variety of other gram-positive and gram-negative pathogenic bacteria may be present in the milk, which get destroyed on pasteurization. Now we will see about the total acidity. Acidity is the free fatty acids are neutralized with standard alkali. The amount of alkali required is the measure of free fatty acids or acidity. Weigh 20 grams of prepared sample in a conical flask and add 50 ml of recently boiled cooled water. Titrate the solution with 0.1 and NaOH using phenolphthalein indicator, and see the color can be employed to judge the endpoint. Now, specific gravity. For water, specific gravity is related to water. The specific gravity is defined as the ratio of the mass of that product to the mass of an equal volume of water at 4 degrees centigrade, the temperature at which water density is greatest. A reference temperature other than 4 degrees centigrade may be used if that temperature is explicitly specified with the specific gravity value. Specific gravity may be calculated from the following expression, that is, specific gravity is equal to mass in air into specific gravity of water whole divided by mass of displaced water. For example, we will see in the oil. There is not much variation in this value from oil to oil. However, oxidation increases this value. The specific gravity value varies directly with the unsaturated fatty acids content. The figure is affected by age, rancidity and other treatment of oil. The specific gravity is measured with a specific gravity bottle or phynometer. The temperature measurement is mentioned. Now, you have seen in food industry, foods are analyzed for chemical composition and characteristics either for nutrition labeling or quality control. The food analysis are carried continue within processing or sampling collected for quality control or sent to outside analytical laboratory. And we have seen about the aspects of textural properties, size, shape, enzyme activity, total acidity, symmetry, pH and water specific gravity. Thank you.